This explainer is provided by Consult Safety and Engineering.
Every single day, our world is powered by these incredibly complex industrial processes. But what holds it all together? Well, it's this kind of unseen shield, a whole system of rules and honestly brilliant foresight that stops disasters before they can even get started. So today we're going to pull back the curtain on the playbook that keeps our world running and running safely.
All right, first up, we really have to get a handle on the stakes here. We're talking about facilities that handle some seriously hazardous materials, where the absolute #1 rule is keeping that stuff right where it belongs. But what happens when that containment fails?
You get this. You get chaos. And look, this isn't just some small, localized problem that's easy to clean up. When you lose containment, a situation can spiral from a tiny leak to an absolute catastrophe in like a matter of seconds. It really is a terrifying chain reaction. One single failure can set off massive fires or explosions. Toxic clouds can drift way beyond the plant's property, and that can lead to injuries and, tragically, even fatalities. The damage to the environment can last for decades, and you can bet the public's trust is just gone instantly.
So that brings us to the most important question. Right, because reacting to a disaster is already too late. The real work, the true genius, is in making sure it never ever happens to begin with. So how in the world is that done?
Well, it all comes down to a super disciplined, systematic approach. The best way to picture it is like a massive, detailed safety playbook. It's filled with rules and procedures that are all designed to manage these huge risks proactively, not after the fact.
Now, this playbook, it's got an official name: Process Safety Management, or PSM for short. And its entire purpose really just boils down to two critical jobs. Job #1, keep incredibly dangerous chemicals locked down tight. And job #2, make absolutely sure that every single risk connected to them is found and brought under control.
And we are talking about some serious stuff here. PSM is specifically for chemicals that are toxic or that can catch fire, explode, or are just dangerously reactive. Pretty much anything you absolutely, under no circumstances, want getting out into the world.
Okay, so inside this whole safety playbook, there's one part that's, well, it's considered the most critical piece of the entire puzzle. It's really the engine that drives the whole system.
And I'm not just making that up. The source material literally calls it the heart of the PSM program. So if PSM is the playbook, this next thing we're talking about, it's the star quarterback. This is where all the real preventative magic happens.
It's called a process hazard analysis, or a PHA. And just look at those words right there: thorough, orderly, systematic. This is not about guessing or just crossing your fingers and hoping for the best. No way. It's a structured, scientific hunt for potential dangers so they can be neutralized before they ever cause any harm.
A really great way to think about it is like industrial-scale detective work. You get a team of experts, and they go over every single inch of a process, looking for clues, a hidden weakness, a tiny flaw, anything that could lead to a disaster, and they solve the case before the crime even happens.
So how does this industrial detective work actually, work? The entire super complex analysis really boils down to answering three simple but incredibly powerful questions.
First question, and it's the most basic one: what can go wrong? This is where you combine serious engineering knowledge with a little bit of, let's call it, creative pessimism. You look at every single pipe, every valve, every step in a procedure, and you just brainstorm every possible way it could fail, no matter how wild it sounds.
Okay, next, for every single one of those what-if scenarios, you have to ask, how bad could it be? This is all about consequences. If this thing fails, are we talking about a small leak that's contained right away, or are we talking about an event that could affect the entire town next door?
And finally, for each of those bad things, you ask, how often might this actually happen? This gets into likelihood. Is it a 1 in a million chance, like a freak lightning strike, or is it something more predictable, like a severe storm that happens every few decades? Answering these three questions together, what can go wrong, how bad can it get, and how likely is it, that's what gives you a true, measurable picture of your risk.
Now, as you can probably guess, answering those three questions isn't a one-size-fits-all kind of deal. Depending on just how complex a system is, these safety analysts have a whole toolkit of different techniques they can pull from to get the answers.
So for example, for a pretty simple general process, you might use a basic checklist just to make sure all the common known hazards are covered.
For a specific piece of equipment, like a pump, you might use something called an FMEA to study every little way that one part could fail. But for a really, really complex system, that's when you bring out the big guns, a HAZOP study, which meticulously looks at every single possible way a process could stray from how it's supposed to work.
So you can really see the range here, right? A checklist, it's simple, it's quick, and it's great for catching the usual suspects. A HAZOP study, on the other hand, man, that is a whole other beast. It's this incredibly rigorous, time-consuming deep dive. It's designed to find those really complex, hidden problems, the kind of thing a simple checklist would just never catch. The key is always matching the power of the tool to the complexity of the job.
So, what's the big takeaway here? At the end of the day, all of these procedures, these analyses, these weird acronyms, they're all doing one thing. They're all building and maintaining that invisible shield.
And this is what that work actually looks like. It's not always dramatic or action-packed. It's engineers and operators and safety experts sitting in a room with a bunch of diagrams, methodically walking through every what if. They are finding and fixing problems on paper so that those problems never, ever get a chance to happen in the real world.
And really, that's what it all comes down to. This systematic foresight, this absolute dedication to asking what if, is the unseen shield that is quietly protecting our communities and making our modern high-tech way of life even possible. We've seen how this proactive, systematic thinking keeps our whole industrial world safe. It's a pretty powerful way to manage really complex risks. And that leaves me with just one final thought for you to chew on. What are the risks in your own life, big or small, that might just benefit from that same level of what-if foresight?